To lecture 2.2 on the Human Development Index. So in this lecture, we're going to be taking a look at an alternative measure of economic development created by the UN, which is the Human Development Index, the HDI. So this index is a little bit more expansive than just using income because it adds in some indicators for both health and education. So mathematically, the HDI is going to be the geometric mean of three sub-indexes for health, education, and income. So the geometric mean basically is going to be you multiply the sub-indexes together, and since there's three of them, we're going to take the cube root of that product. So it's a little bit different from an arithmetic mean where you add them up and then you divide by the total number that you're adding. Here you multiply them together and then you take the root up to the total number that you're multiplying together. So in this case, we have three sub-indexes, and so we take the cube root of that product. Okay. So in general, the sub-indexes are going to be defined as difference ratios. So a difference ratio basically is we take a look at an indicator for the country we're looking at, and then we compare that to the worst possible case scenario, right? And then we divide that by the difference between the best and the worst case scenarios. So the nice thing about this kind of a sub-index is that it's bounded between 0 and 1. So for example, if a country has the worst possible case scenario, then that means that the numerator of this equation here is going to be 0. And so the worst possible case scenario, that sub-index is going to be 0. Now, if the country has the best possible case scenario, then you can see that the numerator and the denominator are the same thing, and then that sub-index is going to be equal to 1. And so this sub-index is going to be somewhere between 0 and 1 for whatever country we're looking at. The closer it is to 1, the closer the country is to the best case scenario. The closer it is to 0, the closer they are to the worst case scenario. So that's a nice way of basically combining together a whole bunch of different variables that are measured at different units. So if we're looking at health and education and income, how are we going to combine those together? The way that we do that is by first converting them into these indexes that are looking at how our country is doing compared to the best and the worst case scenarios. Okay, so in order to figure out what the best and the worst case scenarios are, the UN has established what they call goalposts, which sort of indicate the best and the worst case scenarios for the variables that are comprising the Human Development Index. So health is going to be measured by life expectancy at birth. The worst case scenario here is going to be 20 years. The best case scenario is 85 years. Education is going to be measured using two variables, mean years of schooling, which kind of takes a look at the current education level of the adult population, and then expected years of schooling, which is taking a look at sort of a future look into how educated we expect people will be in the future in that country. So for both of these, the worst case scenario is 0 years of education, and then the best case scenarios for mean years of education is 15 years, and for expected years, it's going to be 18 years. Okay. And then finally, income is going to be measured by GNI per capita adjusted for purchasing power parity. The worst case scenario is $100. The basic idea there is like that's just the absolute poorest possible situation we could think of. And then the best case scenario is going to be $75,000. Now, there are a couple countries that do have GNI per capita, even adjusted for PPP, that's a little bit above this. But that's something we're going to circle back to. Basically, we're going to make the argument that once you get above $75,000, any increases in income really aren't going to have much of an impact on your standard of living. Okay, so let's take a look at the health subindex first. So this is measured using life expectancy at birth. So life expectancy at birth basically is if somebody was born today, how many years would we expect them to live on average, assuming that mortality patterns at the time of birth are going to remain constant throughout the course of their life. And so it's an average. So a lot of the people that are born today, some of them are going to die young, some of them are going to die old, and we basically just average that out. So if you can imagine like 1 million people born today, what's the average sort of number of years of life that we'd expect for them to live? And so the health subindex is going to be computed again as this difference ratio. So we take life expectancy in the country we're looking at, and then we subtract from that the life expectancy in the worst case scenario, which is the goalpost established by the UN at 20 years. And then we divide that difference by the gap between the best and the worst case scenarios, so the difference between 85 and 20 years, which is going to be 65. And so the health index is going to be life expectancy in the country we're looking at minus 20, that difference divided by 65. So for example, if life expectancy in your country is 70 years, then we take 70 minus 20, that's 50, and then we divide that by 65, and we end up with 0.769. So the way that we can interpret this basically is that the gap in life expectancy between the country we're looking at and the worst case scenario is about 77% as large as the gap in life expectancy between the best and the worst case scenarios, right? So it's certainly not the best, but it's further away from the worst case scenario than it is from the best case scenario. Okay. The education subindex is a little bit more complicated because we want to use both a measure of the current level of education and the future level of education in a country. So mean years of schooling basically is, the adult population on average, how many years of education do they have? Expected years of schooling is kids today, how many years of education are we going to expect them to get? And oftentimes we will see that expected years of schooling is going to be a bigger number, right? And so that's consistent with things are improving, countries are investing in education, and we should expect that their education level are going to be higher in the future. So we want to use both of these things. And what we're going to do is basically just take a simple arithmetic average between the difference ratios for mean and expected years of schooling. So remember, the goalposts for mean years of schooling, the worst case was 0, the best case was 15. And so here we're going to take mean years of schooling minus 0, divide that by the difference between the best and the worst case, which is just going to be 15 minus 0. For expected years of schooling, again, the worst case was 0. The best case was 18. And so we take the difference between expected years of schooling and 0 over the best case, 18, and 0. This simplifies down basically to the average of mean years of schooling over 15 and expected years of schooling over 18. So basically you add those two difference ratios together and then divide by 2 or alternatively multiply by 0.5, right? So for example, let's say a country had mean years of schooling of 12 and expected years of schooling of 15. So 12 over 15 plus 15 over 18 is going to be 0.8 plus 0.833. We take the average of those two numbers and we end up with 0.817. So the interpretation here is that the difference in education between our country and the worst case scenario is 81.7% as large as the gap between the best and the worst case scenario. So the nice thing about these subindexes is that you can actually compare them. So remember the health index was 0.769. The education index in this case is 0.817. So this is a country we can already look at and say they're actually doing a little bit better in education than they are in health. They're closer to the best case scenario when it comes to education than they are in health. Now, finally, we're going to take a look at the income subindex. Now, just to make things complicated, now there's a better reason for that. Rather than just using income, as it is, we're first going to take the natural log of income. Now, the reason we do this is that there's a concept called diminishing marginal utility of income. The basic idea here is that as you increase your income, each successive dollar of income is going to generate less and less utility. So imagine there's a $100 bill lying on the street, right? If you are, struggling to get by, and you wonder where your next meal is going to come from, you find that $100, that makes your day, right? That's a huge thing, right? Now imagine Jeff Bezos is walking down the street. He sees that $100. He's probably not even going to bother bending over to pick it up. It doesn't mean anything to him, right? And so the idea here is that an extra $100 is going to mean a lot more when you have very little income than it does when you have a lot of income, right? And so something that captures this diminishing marginal utility in mathematical form that it captures that is the natural log. The basic idea here is that the natural log is going to have a bigger slope at low levels of income, meaning that increases in income are going to lead to bigger increases in utility than big levels of income. High levels of income, that same increase is not going to have much of an impact on your happiness, your utility, your standard of living. So that's the reason why we're taking the natural log. But once we do that, it's the same kind of difference ratio that we're doing. So we take the natural log of income in the country we're looking at, subtract from that the natural log of income in the worst case scenario, which remember was 100, and then we divide that by the gap in the natural log of the best case scenario minus the natural log of the worst case scenario. So this is going to simplify down to the natural log of G and I minus the natural log of 100 over the natural log of 75,000 minus the natural log of 100, which once you do the math, that's the natural log of G and I in our country minus 4.6. That's going to be divided by 6.6. If you wanted to get even fancier, you could say that this is actually going to be the natural log of 75,000 over 100, but we don't need to do that. Okay, so let's say, for example, that a country has G and I per capita of 17,000. So the natural log of 17,000 is 9.74. So you take 9.74 minus 4.6 and then divide that by 6.6, and we end up with another income sub index of 0.779. So again, the interpretation, the difference between income in our country in the worst case scenario is about 78% as big as the gap in income between the best and the worst case scenarios. Okay, so we've got a health index, we've got an education index, and we have an income index, and they're all put into this form that they can now be compared to each other and they can be combined together. And so here we're going to put it all together. We have our health index, our education index, and our income index. And here's just sort of replicating the calculations that we did with the examples that I gave. And to compute the HDI, we're going to multiply all of those three sub-indexes together and then take the cube root. All right, so doing that is going to give us an HDI of 0.788. Now, just a little trick for you. If you are asked to calculate this, and you will be, it might be easier for you using a calculator rather than taking the cube root to raise this product to the 1/3 power. Sometimes it's a little bit faster. So if you can't find the cube root function on your calculator, just raise it to the 0.3333 and you're going to get something close enough. It's the same thing. Okay, so this number 0.788 doesn't really mean anything, right? It's just a number. I mean, the best HDI is going to be 1. The worst is 0. No country has 0. No country has 1. Where it's useful is in comparing it to other countries. And in particular, the reason why I want you to know how to compute all the sub-indexes is we can take a look at this number and we can see where they did well, where they did poorly. And so this is a country that does pretty well in education and not as well in health. And so based on their income, we would expect them to do a little bit better in their health. And they're in fact doing a little bit better than we would expect based on their education. So that's a useful sort of comparison to be able to make. All right, so let's take a look at actual numbers, from the UN, and I mean you can compute these yourself if you wanted to. So here I've got countries grouped by development levels, and this development level is based off of their HDIs. And so you can see that low development countries have HDI around on average 0.5. Medium development's about 0.63, high development's 0.75, and then very high development's 0.892. Okay, and you can see the corresponding income levels, and you can see that the least developed countries have the least income. The most developed countries have the highest income. So income, again, is decent at sort of measuring broad differences in development. It's within these groups that we struggle a little bit to take a look at, relying on income as a sole measure of living standards. Between these groups, we can see life expectancy consistently rises, expected years of schooling consistently rises, mean years of schooling consistently rises. What's interesting, if we actually take a look at regional differences. So, for example, take a look at Arab states, which have an HDI of 0.703 and an average income of about almost $16,000. Now compare that, for example, to either East Asia or Latin America, two regions where average income is actually lower than it is in Arab states, but their HDIs are significantly higher. And the reason for that is that East Asia, Latin America have better indicators for health. People live longer there. They have better indicators for education. And so you can see here that if we were just to rely on income, we would be overestimating the living standards in these Arab states. And so by adding in these metrics for education, these metrics for health, we're getting a more accurate, broader picture of how developed these areas are. What's really interesting also is if we take a look at individual countries, and here they've got these grouped basically by their development level. And if we take a look at the ranking in both HDI and in GNI. So, Norway, for example, has the top rank in HDI, 0.954, really close to 1. But their GNI is ranked 6 in the world. So there are 5 countries that have more income, but they are not as highly ranked in terms of HDI. Right? And if we take the difference between these, this is somewhat telling in terms of whether or not GNI is over or underestimating the level of development in a country. So if the GNI rank minus the HDI rank is a positive number, that means that this country is ranked better in HDI than it is in GNI. Remember, a lower number in ranking is better than a high number. So in particular, take a look at a country like Germany, right? That ranks 15 places better in their HDI than it does in their GNI. So we're really underestimating living standards in Germany if we just look at their income level, right? So, Germany's a rich country, $47,000 per capita. GNI is pretty high. But if you look at also Germany's indicators for health and education, is doing much better than that income would suggest. For example, take a look at Cuba. right, in this sort of middle group right here. Cuba's pretty poor, $8,000 GNI per capita, but their HDI is significantly higher, right? They are ranked 44 places better in HDI than they are in GNI. So the way that Cuba is doing this basically is by having really strong indicators for health and education. So Cuba's doing a lot better than we would expect based off of their income in terms of their health and their education. By contrast, you take a look at a country like Kuwait, which is pretty rich, fifth richest country in the world according to this ranking, but their HDI ranking is 57th. So that's a difference of 52 places. What that suggests is that if we just looked at income, we'd be vastly overestimating the standard of living in Kuwait. This is even more stark if we take a look at a country like Equatorial Guinea, a really wealthy country by sub-Saharan African standards, but mostly on the back of vast natural resource wealth. And their difference in rankings between their GNI and their HDI, they're ranked 80 places lower in HDI than they are in GNI. So we're vastly overestimating the standard of living in Equatorial Guinea if we actually just look at GNI. A pattern that actually does emerge is that countries that are reliant upon natural resources tend to have income levels that are far above their indicators for health and education. And the reason basically for that essentially is that you've got, a lot of income inequality in these places. You've got a few people that control that oil wealth and they're really rich and they're bringing up the average income. But the majority of the people in the country are not necessarily benefiting from that oil wealth. Now, some of it does get reinvested, but a lot of the times what we tend to observe is that countries that are reliant on natural resources suffer what's known as the resource curse. They should be doing really well. They've got this great wealth in their country, but we tend to see that countries that are abundant in natural resources and rely on those natural resources actually have some of the slowest growth rates across the world. So the HDI is certainly an improvement upon GNI, but it's not perfect. And there are some pretty valid criticisms of the HDI. So first off, it is a single number for the entire country. But of course, there's a lot of differences within countries. So I want to show you two different tables here. The first is taking a look at Guatemala. So Guatemala's average HDI is just a little bit below 0.7. But if you actually look at the Human Development Index computed for specific ethnic groups in Guatemala, you have sort of the majority Ladino population, which is a little bit better than the average. And then you have some indigenous minorities that have development levels that are far below the average there. And so if we were just to take that whole number for Guatemala, we would be overlooking, a lot of the development inequality between these ethnic groups. Over on the right here, we've got China. And we can see that the average HDI for China is about 0.75 or so, but there's big differences depending upon where in China we're talking about and whether we're looking at urban or rural. So, for example, urban Shanghai is one of the more developed parts of the world, right? I mean, it has a development level on par with Greece, for example. Rural Shanghai, lower level development. If we go all the way down to Guizhou, urban Guizhou's about the average level of development for China, but rural Guizhou has a development level, beneath that of Cambodia. And so we really do need to consider that, this HDI has given us a picture for, the average in the country, but there can be some pretty severe differences within countries, whether we're talking about differences between ethnic groups, differences geographically, differences between urban and rural. We need to take that into account. Okay, other criticisms. There's nothing in there that says about the quality of life or the quality of education. So we're looking at how long people expect to live, but how good is that life, right? We look at how many years of education people are getting, but what are they actually learning, right? If somebody's getting, 12 years of education, but, they come out of that not being able to read, not being able to do, basic math, right? That's a concern. So why not actually use more outcome-based measures? Why not look at literacy rates, scores, and standardized tests? Instead of using life expectancy, we could use something called disability-adjusted life years, right, which accounts for health and environmental considerations for the standard of living that somebody has. Other issue: we equally weight health, education, and income. Should they be? Right? Maybe education is more important. Maybe health is more important. Maybe income is more important. And in fact, there might be some countries where health is the most important thing, other countries where education is the most important thing. So maybe we should have a more sophisticated system, some kind of algorithm that actually determines, what the optimal weighting scheme should be. Now we do this, we equally weight it, which is it's simple, it's easy to compute, easy to understand, but it does not necessarily mean that it's going to be the most effective measure of development. And then another issue we run into is really systematic data biases. So we rely upon national accounts data to compute these HDIs. And a problem we might run into is, let's say that we are looking at really authoritarian states, so countries that aren't open, they're not democratic. We tend to observe that those countries have really strong control of information. That's one of the ways that sort of despots are able to rule, is that they take control of the media, they take control of information, and they basically tell the narrative. So let's say you've got an authoritarian state that is really not doing a good job, right? But it's able to sort of twist the statistics, and it makes it look like education numbers are a lot better. Life expectancy is a lot better. So the problem we run into is that if we are systematically overestimating health and education in these authoritarian states, then let's say we use the HDI to try to estimate, are democratic countries more developed than authoritarian countries? Well, if authoritarian countries are, overestimating their life expectancy, their education numbers, then we might come to the conclusion that no, there's no difference between authoritarianism and democracy in terms of development. But that's not necessarily the truth. That simply might be a result of these data biases. So we need to be a little bit careful that we are relying upon national accounts data. And then finally, it doesn't consider environmental sustainability at all. And again, what we're seeing is that environmental factors are critically important to development, especially in developing countries.